Hey, I just want to go through and pretty much fill this out again with you. Because in 2 days, I'm going to give you a blank one just like this and say, here you go, fill it out. Radius is always 1. It's a unit circle. Yeah, so not to give you test anxiety or anything, but yeah, in 2 days, you're going to be staring at that and asked to put all those numbers on there. All right, so start with we have 0 degrees. Oh, you want to do 360 and 2 pi? What? Yeah. Oh yeah, no, I got tons of blank ones. Here. I'm just getting away from them. Huh? Practice. Just for practice. And again, you guys can take as many as you like. If you want blank ones to practice at home, take blank ones to practice at home.
Where are the blank ones at?
In Valeria's hands. Because
can I have like 6?
yeah, there's like too many of you.
Yeah, can I have
I'm
a
afraid I'll get touched by a teenager.
No, seriously, I'm full stack.
That's scary. Getting touched by anyone is scary.
What?
I don't like people touching me. Or anywhere inside my big round plastic bubble.
Plastic?
Yes, it's plastic. Hard, crunchy plastic. Not brittle. The kind that you run into and hurt yourself whenever you bounce off. And then she takes the rest of the pile for herself.
Thank you. If there's something that you want to do before you die,
I'll take the
name
whole.
one thing.
Make sure you say this one because we need coffee.
I'm gonna do this exactly dirty.
Okay. How much tape do you recommend?
I have the digital copy. What are you talking
Like
about?
like three. Okay, there's 2 days left.
All right, good. Just take a handful.
What do you want to do before you die? You did the 100-thing assignment, like you should.
I know.
If you put live, right? 50 of them.
I put make a scholarship and then have it.
Hey, you guys think I'm kidding?
What?
You have more?
Make, I don't know, make more blank units or
I take this serious.
Learn the unit circle.
pass trick.
Okay, so we can say 360, 2 pi here. What's this line here?
30 degrees.
Or do you want me just to shut up and let everyone fill it out on their own? Yeah. Okay. You fill it out. I'll stand here and fill it out. And then you can compare. Yeah. Oh, I thought you guys were trying it on your own. No, you do it. I don't want to talk. I can't talk. I thought we were racing. Bless you. I'm done. Did you beat me, Dante? Did you beat me, Dante? It's like the halves and the square root of 3. Oh, well, that's okay. Just cross out the y and put it on the other side. That happened. Yeah, cross it all out and redo it.
Race it all.
Oh no, we have real notes.
Real nose?
Notes. Yeah, real nose. Like this one here.
I was thinking of like Pinocchio. I want to be a real boy.
All right, I don't spend forever on this, so that gives you kind of an idea of where you're at, your difficulties. It shouldn't take you a full hour. I'm going to give you the quiz, and then I'm going to give you time to work on homework. Yes. I'm not going to do notes afterwards. No.
Wait, how many minutes are we start? Do another time one?
Yeah. Okay, so any questions or concerns about how any of these numbers come about, or you want me to move on? Yeah. The rest of them are right, just that one. But yeah, once you get your first quadrant ordered pairs, those ordered pairs go with all the rest of them. So this ordered pair matches this ordered pair, and this ordered pair. All you have to do is change signs. Works the same way with the 45-degree ordered pair. Works the same way with the 60-degree ordered pair. They match in all the places. You just have to make sure you get these order pairs correct so you don't take an incorrect order pair and drag it around to the other places. No. Hello. Oh, there's no one there. Okay. Trig functions. All right, so we defined the first three yesterday. Sine was y, cosine was x, and tangent was y over x. So we could just use the order pairs and get the values. So using our reciprocal rule that we talked about a couple days ago, we can do the same thing with cosecant. Oh, I need to put a theta in there. Cosecant of theta is defined as 1 over y. So I just take the y value and do the reciprocal of it. Secant, which is the reciprocal of cosine, is going to be 1 over x. Cotangent is x over y. So there's all 6 of your trig functions defined on the unit circle. So let's go through and practice this again, and then we're going to do a little bit that's new. You can do this anytime you want. All these definitions for your trig functions, you really do it based on what your problem looks like. Like if you're given a triangle in your problem, you're going to want to use the definition of the triangles for your trig. If you're just given a value, it depends on whether it fits into this or not. If it fits into this, then great, use this. If it's a random angle, you're going to want to use your calculator. All right, so sine of 5 pi over 3. So the way we use this, we go to 5 pi over 3, so that's right here. Sine is the y value, so I go to the order pair. Y value, I wrote a little small, is negative square root of 3 over 2. What? So there we go. That's it. Okay. Secant of pi over 6. So I go to pi over 6. Secant is 1 over x. So that's 1 over square root of 3 over 2. So that'd be 2 over square root of 3. If I simplify that, that would be 2 radical 3 over 3. Remember, quick way of doing the simplifying this is you just move the radical to the top, and whatever number's inside, just leave one of those numbers down there. That's the quickest way of... that kind of shorts you out of the whole meaning behind it, but it's a shortcut. We're assuming you already know the meaning behind it, and you just want a shortcut of doing it. Get what? This. Take the radical and move it to the top. And since there's a 3 inside, I leave a 3 on the bottom. Okay, so cosecant of negative pi over 3. So I have to go backwards. I should put that in parentheses. Negative pi over 3 would be down here. Cosecant is the y value. I really should have watched what I was doing and mixed that up a little bit, but cosecant so since I just did that one up above, I would just be negative 2 radical 3 over 3. Okay, cotangent of 2 pi over 3. So find 2 pi over 3, which is right here. Cotangent is x over y. So I take the x value over the y value. So that'd be negative 1/2 times 2 over radical 3. So my 2's cancel out, so I'd have negative 1 over radical 3. Yep. So it'd be negative radical 3 over 3. Okay, let's do a couple of the weird ones. Okay, cosecant of pi. So cosecant is 1 over y. So that one will be undefined. Okay, where's 4 pi? Yep, that's around 2 times. So if I go around once, that's 2 pi. I have to go around again to get to 4 pi. So it'd still be right here. So cotangent is x over y. So the x value is 1. The y value is 0. So that one's undefined also. Okay, calculators. Now, you have to be careful with these.
Like, do you have, like, so if you're trying to solve a radical, a radian for the, trying to get, I just don't know when to put the, like, have it radians and then the other one. I don't know when you set it for which.
When it said to radians or degrees,
Yeah.
just depends on what the problem asks for.
So
Like-
if I'm trying to give degrees, do I set it for degrees?
Yes.
Okay.
Well, okay. Yeah, if the problem, like, if the problem gives, your answer doesn't have any sign on it whatsoever because your answer is a ratio. But this problem doesn't give you units, so this problem's giving it to you in radians. This problem's giving it to you in degrees. So this problem you're going to set it to radians. This problem you're going to set it to degrees.
Oh, so you set it to whatever you already have?
Yeah. Now, you don't have these buttons on your calculator, so you have to do it one of two ways. You can set it like this, or you have a button on your calculator that looks like this. It either you have an X -1 button or something like that. Either of those buttons will do the same thing. No, do not use the button that looks like this. That button does an inverse cosine. That's something entirely different, so do not use that button. So you either need to use division or use the button that looks like this. So I don't know if you can see that too well. I did both of them. I used the -1 and the 1 divided, and both of them gave me the same answer. Just to show you that they both work the same way. So each of them gave me -2.40. Okay, that's, yeah.
So why did you put the 1 over cos?
Because secant is 1 divided by cosine. You have to use the fact that it's an inverse because you don't have a secant button. So in order to do this in the calculator, we have to use the fact that secant is equal to 1 over cosine. So same thing with cotangent. You either have to use the fact that cotangent is equal to cosine over sine. You can do it that way, or you can use the fact that it's equal to 1 over tangent. But you have to use one of those two properties to solve it, because you don't have a cotangent button. So you should end up with 0.12. If you didn't get that, make sure you changed it back to degrees. Again, just to prove it to you, I did it both ways. I did 1 divided by tangent 83, and I did cosine 83 divided by sine 83. Both of them gives me the same answer. But those are just using those rules that we had last time. All right, I'm going to switch that. Okay, last little bit. These are kind of new things that they introduced in this chapter. The odd and even isn't terribly useful, but it's something you should see. I don't remember how much you remember from first semester, but we talked about odd and even functions first semester. Even functions were functions where if I plugged a negative value into the function, the answer was exactly the same as if I plugged the positive value into the function. So a good example would be x squared. That was an even function. An odd function, if I plug the negative, then I got the negative answer out. All right. Cosine and secant are both even. Sine, cosecant, tangent, and cotangent are all odd. And a big reason has to do with your unit circle. You can see this on the unit circle. If I plug pi over 6 into cotangent, I get square root of 3 over 2, correct? If I plug negative pi over 6 into cosine, negative pi over 6 would be down here. I would also get square root of 3 over 2 because cosine has to do with the x values, correct? Well, over here in this quadrant, x values are both positive. Well, if I would come over here, the positive angle over here and the negative angle would both be in these two quadrants, which would both give me negative x's. So they're always mirrored because of the quadrants. Well, sine and cosecant do y values. Well, whenever you're mirroring like that, you're going to get a positive y value and a negative y value all the time. So that's going to give you odd functions. Well, tangent and cotangent, because sine is odd, they're going to be odd because they involve sine. So that's the reason why they're even and odd. Again, it's not a super important thing. It's introduced. It's a good thing to see, but it's not a make it or break it topic. Okay. Oh, sorry. Period and range are introduced. It's a good thing to get started on.